Okay. Okay, so here is your warm-up. We have done this before, looking for the x and the y intercepts. Okay, so that's that one. This should have said months, obviously. Great. If you did 24 weeks, that would have been perfect. Okay. 6 times 4? 6 months. They'll each have 11 pairs. Okay, 6 months, 11 pairs. All right. So, good, right? Like, I want it to be easy. Okay? It's a little easier to fill out. Okay? And so you're saying like this. Starts with 7. So initially, there's 7. And then some of you are getting pretty... there's a lot of conversation over here about like, well, right, technically Jordans, you can't really split them in half. It doesn't make sense. And so here... Here they were saying, well, if it's happening, if she's getting 2 more every 3 months, or he is, then let's just look at every 3 months. So in 3 months, what's your new total? 9. And then in 3 more months, 11, and 3 more months. Wait, hold on. That's not 3. Okay. Hey. So here's where we struggle then. Because, right, it doesn't make sense to have a third of a shoe. Okay? So look, hold on. The tables are coming out pretty good. The harder part is people are having a harder part writing the equation. So let's look together. Okay, if you don't know how to write the equation, you might help you to pay attention real quick. Okay? How many does Jason start out with? 7. It says 7, right? So I say y equals 7. That's how many he starts with. And then he gets 2 more, but it's every 3 months. So this, if you wrote 7 plus 2x, if you wrote 7 plus 3x, you need to change it. If you wrote 7 plus 5x, you need to change it. Okay? Yeah. If you wrote anything except for this, fix it. Okay? I don't want you to write 0.66 because it's not exact. Okay? It never ends, right? So here, look, this is what this says. It says you start with 7, you get 2 more every 3 months. The same thing when we graph it, right? On the graph, I would start at 7, and I would get 2 more every 3 months, just like I would do for my slope. Right? And I would use my graph, and I would make my line, and everyone would be so happy. There's a graph. Okay? So that's for Jason. Then we're looking at Stacy's equation. And again, it's easier to look at the table. She starts out with 5. So I say initially she starts with 5. We talked about the 0 last time. Please double check that your partner has starting with 0 on their paper. Check their paper. Do they have 0? Check their paper. Check their paper. Do they have the 0? Okay. You have to have 0 everywhere.
0 everywhere?
Really, you should start at 0 each time, yes. Check it. Okay. Now, it says Stacy Stacy gets a pair every month. So in 1 month, 6. In 2 months, 7. She's rolling. 4, 5, 6, 9, 10, 11. So again, if we look at this table, when we look at the table, when are they exactly the same? Look at the table. 6 and 11. This, notice it's the exact same on the table. 6 and 11. If I put it on a graph, starts at 5, goes up by 1. Where will they cross? Right? It should be the same point on the graph. It's the point 6, 11. It's the same in the table. It's the same on the graph. Okay? When we start solving systems using algebra, it'll be the same that way too. Okay? It always has to be the same. So look, this should make sense to you guys, right? Like, all of you in here are bright enough to be like, yeah, that's the same, that's the same, that's the same, right? Like, it's not tricky. They should be the same. So I want you to keep this in mind, because when we start solving them, like when we start solving our revenue equations, it should be the same on the graph and on the table and when you solve it. If it's not the same, it means something happened. Okay, it should make sense. I know sometimes we think math doesn't make sense, but it... Do one of you need to move? So we're going to do that. We have 3x plus 5 times 0 equals negative 12. Okay? And then I solve this equation. What's 5 times 0? 0. So you get 3x equals negative 12, because 5 times 0 is 0. So what do I got to do with that 3? This is 0, so that's gone. Why divide? Because it's 3 times x, and we need x by itself. So the opposite of multiplying by 3 is dividing by 3. Yes. So x is negative 4, which means the x-intercept is negative 4, comma 0. Right? The x-intercept is a point on the graph. So we write it as a point. This is the x-intercept, yes. Okay. And we would do a very similar process when we're solving for the y-intercept. It's almost exactly the same. But now, to solve for the y-intercept, what do we do? Right? It's opposite. So we plug in 0 for x this time. No, back into our equation. Back up here. Plugging in 0 for x. So 3 times 0 plus 5y equals negative 12. And again, what's 3 times 0? 0. So we're just left with 5y equals negative 12. So what do? Divide by 5 on both sides. So y equals negative 2.4. Is that right? Yeah. So then again, our y-intercept then, as the actual point on my graph, is the point 0 for x, negative 2.4 for y. Right? This is the y-intercept. The other one is the x-intercept. Okay? Yeah. Okay. Before we get to that, the one thing that I want to look at with you guys, yes, Friday. The one thing I want to look at with you guys is just real quick, again, is looking at, we are starting systems of equations. Okay, so systems of equations is when you have more than one equation. Right, when you have more than one equation. So we're going to do very similar to what we did last time. You guys are going to get two different situations, very similar to last class. You guys are going to have 10 minutes, right? So 10 minutes, that's 5 minutes per situation. And you get one question per group. Okay? What, Andrew? No, in 10 minutes. That was your question? Absolutely. Okay. Any questions in general? I don't think so. Huh? Yeah. We'll see more as we go. It's when you have two things you're looking at.